Welcome to our YouTube channel. In this video, we are going to do wind load calculation based upon IBC 2012. In the right hand side, you can see IBC 2012 in PDF format. So this is the International Building Code. In the left hand side, you can see an Excel sheet which is developed to demonstrate wind load calculation as per IBC 2012. In this calculation, we are going to do in alternative all height method. The definition for this alternative height method is given in IBC 2012. For that, we have to refer page number 385. So it is in the section 1609.6 alternative all height method. The definitions are given here. So let me go to the calculation now. For that, basic wind speed V is required. This is generally is available in a technical specification, or if it is the project is within the USA, we can able to find out from figure 1609A to 1609C. So for that, page number 381 to 83 to be referred. 381. So this is a map showing the wind speed. So likewise, there are three maps. So for our demonstration purpose, we can consider 120 mile per hour. So that is equal to 54 meter per second. Next one is the exposure category. This is as per the project location and around its obstruction which are exposed to wind. So the exposure category, the categories are defined in section 1609.4.2 of IBC 2012. For that, page number 384 to be referred. Here you can see the various exposure categories are defined here. There are three exposure category B, C and D. So the same is extracted to in this Excel and added in the tables of code reference. So while selecting this drop down list, we will be getting the definition of the same here. Next one is velocity pressure exposure coefficient. We need to find out KZ. So for that, section 1609.6.42 to be referred. Page number 385. So in the PDF file, you can see section 1609.42. Velocity pressure exposure coefficient Kz shall be determined in accordance with ASCE 7 section 27.31. So it is suggesting to go for section 27.31 of ASCE 7. So in the screen right hand side, you can see ASCE 710, which is the code to be referred now for velocity pressure coefficient. So for section 27.8, we need to go page number 308. So here is a pressure coefficient which is depends upon the exposure category and height of the structure. So here we can consider the height of the structure as 20 feet for our demonstration purpose. And based upon this exposure height and exposure category, here you can see the table 27.31 which is added here, which is the value or extraction of the PDF file shown in the right hand side. So based upon the exposure category, the values are extracted from the table according to the height, the same is filtered out again. We can get it the value here as 0.9. So in the table in the right hand side of PDF, you can see that for 20 feet height, for category C, it is 0.9. Similarly for B, it is 0.62. So let me consider exposure category as C, but in D, it is 1.08 again. So thus, this is a method to find out velocity, pressure, exposure coefficient. Next one is we need to find out the topography factor Kz. So before that we need to find out the net pressure coefficient C net. So this is as per table 1609.6.2 of IBC 2012. For that page number 386 you have to go. Sorry, it should be in IBC 2012. So here you can see net pressure coefficient based on KD or GCPA in accordance with the table 1609.6.2. So here it is. So we are going to consider the main wind force resisting frames and systems. There are various other structure systems also like components and cladding not in area of discontinuity roofs and overhangs. Components and cladding in areas of discontinuities, roofs and overhangs, which is continuation. So likewise there are some 4 to 5, yeah, 5 numbers of different kind of structures. So we are considering main wind force resisting frames and systems, non-building structures, chimney, tanks and similar structures. Under that we are going to calculate CNet value for flat surfaces. If the flat surfaces is having a solid ratio 0.1, it is 1.45. It is, if the solid ratio is in the range of 0.1 to 0.29, it should be 1.3, and 0.3 to 0.7 means it is 1.16. So it is given here. We are assuming the ratio of solid area to gross area is 0.25. So accordingly, the calculation is done here in tables of code reference sheet. So this is a table to calculate this. So if we are considering 0.25 as solid ratio, then the net pressure coefficient C net is 1.34. Also you can check if you are considering 0.2 as a solid ratio, means then the value of C net is 1.38. If it is 0.3, again it is 1.3. So let me consider 0.25. Next one is we need to define the topography factor. So for that is section 1609.6.4.2 to be referred, page number 385. So here you can see the KZT shall be determined in accordance with the AACE 7 section 26.8. So in this AAC 0710 we need to find out the topography factor KZT. So for that page number 299 to be referred. So this picture showing in the Excel sheet is both of escarpment 2D ridge or 3D axisymmetrical hills. So we are going to consider, say for our project location is having a 2D escarpment with a slope of the hill 1:3. Height of the hill from ground, average ground, is 150 meter. So that Hx, LHZ value are shown in this picture, except the Z value is not shown. Z value you can see here, it is a height exposed to wind. So LH is the distance at which where the total height of the hill should be half of the hill to the top peak or the crest of the hill. So that is a distance. It is a horizontal distance. Similar like this LH distance is calculated as the slope we are having is 1 in 3 and height is 150. So 150 into 3 divided by 2, as we are taking half of the distance length alone. So then distance of upwind we got calculated, and height exposed is we are considering here as a 20 feet. So the 20 feet is converted into meter is 6.1 meter now. So based upon the formula given in ASC 7 2010, you can see here K is equal to 1 plus K1 into K2 into K3 into K through whole square, whereas K1 to be determined by using this table K1 divided by H by LH, and based upon the exposure factor the value is to be calculated, and K2 here the formula is given 1 minus X divided by mu LH. Similar like for K3 also e power minus RZ divided by LH. So this table are extracted here in this Excel and worked in background to find the multiplier of K1, K2 and K3. So likewise K1 is 1.25, K2 is 0.56 and K3 is 1. So simply applying this formula given in ASC, Kz equal to 1 plus K1 into K2 into K3 whole square. We are getting Kz as 2.93. And finally, we are going to calculate the design wind pressure P net. This is as per section 1609 6.3 of IBC 2012. For that, page number 386 of IBC 2012 to be referred. 385 page number. So here is a formula you can see. P net equal to 0.00256 V square Kz C net into Kzt. So we are having Kzt here. C net just we had calculated as 1.34, and Kz velocity pressure exposure coefficient Kz is 0.9. So applying all this input in this formula, 0.256 V square is 120 mile per hour, Kz 0.9, C net 1.34, Kz T is 2.93, and finally we are getting 130.27 pound per feet square. The same is applied using the conversion. We are getting 6.24 kilonewton per square meter. So that's all about the calculation of wind load based upon IBC 2012. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.